Good evening. My name is Anvesh, and today we'll be looking at the solutions for the week 4 for the course Interfacial Fluid Mechanics. So this is just so this will be week 4. Okay, so so we'll begin first. So the first so the f- So the first question says a bottle of 1 liter water is carefully emptied on a smooth floor that is hydrophobic in nature. If the water spreads out in a uniform circular puddle with a contact angle theta e, which is one given as 120 degrees, what is the approximate radius of the puddle? First, let us make the diagram for this. Um, if we look at the top view, so there's a solid surface, and then in that we have a circular puddle. We are asked to find, so we are given that. First, let me get some space. So it is given that 1 liter of water and the contact angle is given as 120 degrees. So what, sorry, it is what is given. It is given that rho water, mu water, gamma of gamma of air water, and the contact angle theta e is given as 120 degrees. So the question asks, find the radius of the puddle. So let's say the radius is capital R. So from our from the notes and as shown in the lectures, the formula for the radius of the puddle is given as under root V by 2 LC pi sine theta e by 2. Also, I forgot to mention here, the volume V is given as 1 liter, which is equals to 0.001 meter cube. So it's straightforward. If we substitute the values, we'll get the radius, but first we need to get LC. So the formula by now we know for LC is gamma by rho G, which is equals to 0.072 for water. We'll take 1000 for water into 9.81. From previous experience we know that this is 2.7 into 10 power minus 3 meter. Substituting the values into our equation, we have R is equals to 0.001 by 2 pi into 2.7 into 10 power minus 3 into sine of 120 by 2. If we solve for this, we get R is equals to 26.08 centimeters. So therefore the correct option is D. So there is a connected problem which says for the problem given in the previous question, what is the height of the puddle? So if we now look at the side view, we have so it's now asked that what is the height of the puddle edge. This time we are asked in the question what is the height of the puddle. So the question we'll ask the height of the puddle h. So if we see from the notes, we have seen that the height of the puddle is given by the expression h is equals to root 2 LC into root 1 minus cos theta e. So we already have, we know LC. LC is equals to 2.7 into 10 power minus 3 meter. So therefore we substitute, and theta e is equals to 120 degrees. Therefore we substitute this root 2 into 2.7 minus 3 into minus cos 120. So if we simplify, we'll get h is equals to 4.6 mm. So the correct option here is B. Okay, now to reduce some space. Sorry. So in the third question, it says it it is common experience that if a small amount of liquid is trapped between two horizontal plates, then it is difficult to separate the two plates without exerting a large amount of force. If the gap between the two plates is h and the approximate radius of the liquid is r, where r is greater than h, then what is the expression for the force of adhesion? And then the hint is given that we need to calculate the pressure inside the liquid. Let's read out this diagram and see um, how does it like. Sorry. This. Let's say it's given r and the height is h. So the height is h and the radius is r. So now it's also given that the the angle of contact at all surfaces is theta e. So it is asked force of adhesion. So first we will use the Laplace equation to calculate the pressure inside. So we have the Laplace equation. The Laplace equation gives del P is equals to 2 gamma by R mean. So we need to find out the R mean here. So if we look at this in a, okay, I'll use a different color. Use a different color. If we look at the zoomed in view shown in green, we have if we extend the circle, okay, let's say we have extended this circle. So now we have, if this is the center, so very close to the contact point we have theta e, and let me just redraw it here, theta e. And if we see that the height, this height is h by 2, so let's say the projected normal here is B, the point of contact is A, and the circle, the center of the circle is O. So let me get some space here. So if we look at the triangle, in triangle OAB, we have this angle is theta e, which is written, this angle is 90 degrees, then this angle has to be 90 minus theta e, 90 minus theta e, so automatically this angle becomes theta e. So if we take here the length of the radius of this circle is r mean that we are trying to find. This gives us the curvature. So we can say that r mean cos theta e is equals to h by 2. So rearranging, we'll have r mean is equals to h by 2 cos theta e. Substituting this into our Laplace equation, I'm sorry, this Laplace equation doesn't have the 2. So substituting it into the Laplace equation, we have delta p is equals to gamma by h 2 cos theta e. Substituting, we have substituted r mean. Then we have the pressure. The pressure is given by 2 gamma cos theta e by h. So this force, if we look at the top view, this pressure will be acting on the radius r, and therefore we have the pressure on the plates will be the force of adhesion will come from multiplying F adhesion will come by multiplying this extra pressure with the area, which is equals to 2 gamma cos theta e by h into pi r square. Therefore F adhesion comes out to be 2 pi r square gamma cos theta e by h. So therefore we get the correct option is B. F adhesion is equals to 2 pi r square gamma cos theta e by h. So the key in solving this question was to identify there is a pressure, the pressure inside, the buildup of pressure inside due to the presence of curvature at the boundaries. Boundaries here and here, and this pressure is uniform throughout inside, and this acts on the plate. So the next question is question number 4. At equilibrium condition, if the spreading parameter S is equals to 0.023 and surface tension gamma, which is equals to 21 millinewton per meter, which of the below options is correct? So given we have S is equals to 0.023 and the surface tension gamma is given as 21 into 10 power minus 3 Newton per meter. So, what is the which one of the options is correct? So, the correct options are given in terms of angle. So, we know from the formula of cos theta e, we know cos theta e is given by s plus gamma by gamma. So, this essentially makes the 0.023 plus 21 into 10 power minus 3 by 21 into 10 power minus 3. So this makes our value of cos theta e greater than 1, which is not possible. Therefore, no contact line. So the correct answer to the solution is that no contact line is possible. In this question, consider a 2D sessile drop in equilibrium on a curved substrate. The equation of the drop is given by z is equals to h of x, and the shape of the substrate is given by the function f of x. If theta cap is the angle between the drop and the horizontal, and theta is the angle between the curved substrate and the horizontal, what is the expression for the modified Young's law? The notation for the quantity is same as that used in the course. So theta is the angle made by the curved solid substrate, and theta cap angle made by the liquid with the horizontal. So so the Young's law says that says that if gamma cos theta e is equals to gamma solid minus gamma liquid gas, solid liquid, solid gas and solid liquids, where theta e is the equilibrium angle between the tangent of the liquid and the tangent of the solid at the point of contact. So if we see closely here, if we see a zoomed in view, if we make the tangent so if we look closely, the theta e is the equilibrium angle for this particular case, where the black shaded region is the solid and the blue region is the fluid. So for us, we can say that the local equilibrium angle theta e is equals to theta hat minus theta. Therefore, we have gamma cos theta e minus, so substituting theta e, we have theta cap minus theta is equals to gamma solid gas minus gamma solid liquid. Therefore, the correct option here is D. Cos theta cap minus theta is equals to gamma solid gas minus gamma solid liquid divided by gamma. I'll quickly take a 5-minute break. So in the next question, we have using the method of Lagrange multipliers, determine the location where the maxima of the function fx comma y comma z, which is equals to 3x square plus 6y square, occurs on the constraint given by the curve g of x comma y, which is equals to x square plus y square minus 9, which is equals to 0. So given fx comma y comma z is equals to 3x square plus 6y square, and constraint sorry g of x comma y, which is equals to x square plus y square minus 9. So we have to define the Lagrange polynomial, which is equals to f of x comma y comma z plus lambda times g of x comma y. So we have to, which means L is equals to 3x square plus 6y square plus lambda times x square plus y square minus 9. So we have the system of equations dl by dx comma dl by dy comma dl by d lambda. We know that lambda is a function of x comma y comma lambda, x comma y comma lambda, and the equations are dl by dx is equals to 0, which implies 3 into 2x plus 2 into lambda into x is equals to 0. Del L by del y is equals to 0, which is equals to, we have 6 into 2y plus lambda 2 lambda into y, and finally dl by d lambda is equals to 0, which implies x square plus y square minus 9 is equals to 0. We need to solve these equations. First let me get some space. So the equations that we need to solve are 6x plus 2 lambda x equal to 0, 12y plus 2 lambda y equal to 0, and x square plus y square minus 9 equal to 0. So in the first case 1, we will assume, so we look at the first equation. So x into 6 plus 2 lambda equal to 0. So in this case, either x can go to 0, or 6 plus 2 lambda can go to 0. So either of it is possible. So in case 1, we'll assume that x is arbitrary and will be found further in our calculations, and instead we'll make this term go to 0. So that will give us, this implies lambda is equals to minus 3. Okay, so now we have the second question, which says that y into 12 plus 2 lambda is equals to 0. So by substituting lambda equal to minus 3 into this equation, this turns out to be 12 plus, I'll write it in a different color, 12 minus 3 into 2, 6. So this term is not equal to 0, and therefore for this equation to hold true, y has to go to 0. So this implies y is equals to 0. So substituting the value of y into our constraint equation, we have x square plus 0 square minus 9 equal to 0. This implies x is equals to plus or minus 3. Okay, so now the set of solution x comma y is equal to plus or minus 3 comma 0. In case 2, we'll assume y into 12 plus 2 lambda is equals to 0. Make this term go to 0, which will give us lambda is equals to minus 6, and then we'll have x into 6 plus 2 lambda, which is equals to 0. So substituting the value of lambda, we get 6 minus 12, which is not equal to 0. Therefore x has to be equal to 0 for this equation to hold true. X equal to 0, and substituting x equal to 0 into the equation, we get x 0 square minus y plus y square minus 9 equal to 0, which implies y is equals to plus or minus 3. So now we have the second pair of solutions, x comma y, which is equal to 0 comma plus minus 3. Now we have to check, this is point 2, let's say, and this is point 1. So we are asked to find the maxima. Maxima of the function this is. So we have found 2 points here. Point 1, which is plus minus 0.1, which is this, and then point 2, which is this. Therefore we need to find the maxima. to find the maxima point, we substitute the values f plus minus 3 comma 0 comma 0 into the equation, and then remember fx is given by fx comma y comma z is given by 3x square plus 6y square, so which basically is 3 into 3 plus or minus 3 whole square, plus or minus won't matter here as it's a square, plus 0, which is equals to 27. This is for point 1. So, and for point 2 it is f0 comma plus minus 3 or 0, which is equals to 0 plus 6 into plus or minus 3, it won't matter, whole square, which is equals to 3 square, which is 9, into 6, which is 54. We see that the function has a maximum at point 0 comma plus or minus 3, that is this value. Therefore the answer to the question is the maxima lies at the point, it's only given plus 3 here, so this. X comma y maxima is at 0 comma 3. So the second follow-up question was, for the constraint problem given in the previous question, what is the value of the maxima? As we have seen that the maxima is 54. I'll write that down again. The 0 comma 3 comma 0, which is equals to 3 into 0 square plus 6 into 3 square, which is equals to 54. Therefore the correct option is C. So this is a question. Consider light traveling from point P in medium 1 with the constant speed c1. Here it's saying it's moving at c1 in medium 1, and to a point P2 in the medium 2 with speed c2. So what is the relationship between the speed of the light in each medium to the geometry of the light ray? And we are asked to use the Lagrange multiplier to minimize the time taken by the light object to the constraint the line is traveling net horizontal distance of x1 plus x2. So the net distance is x1 plus x2. So let's see, this is basically the Snell's law, as we have all seen. We are asked to derive this using the Lagrange multipliers. So find what they are asking. Find Snell's law using Lagrange's multipliers. First, let's make the diagram. Redraw the diagram here, and let's say so we have the point P1 here and P2, and the angles are given as theta 1, theta 2. So the height here will be y1, here it will be x1, here it will be x2, and y2. And this is the lower medium. So in the upper medium we have speed c1, and in the lower medium we have speed c2. So let's say that so this is the figure, and let's say x1 plus x2 is fixed and constant L. So we need to minimize the time taken. So we will write the transit time, the time traveled can be written as the so we want R1, R2. So the transit time will be, let's say it's T. T is equals to R1 by C1 plus R2 by C2. So how do we write R1? So in the triangle we can see cos theta 1 is equals to y1 by r1. So this implies r1 is equals to y1 by cos theta 1. Similarly, we will have r2 is equals to y2 by cos theta 2. Simple trigonometry, we'll get this. So if we replace, we have, sorry, we have t is equals to y1 cos theta 1 by c1 plus y2 by cos theta 2 by c2. And then the fixed distances are x1 plus x2, let's say L. So we have distance x1 plus x2. So x1 and x2 needs to be written in terms of the angle. So x1, so again in the triangle, in the top half of the triangle, in this triangle, we have we have sorry, tan theta 1 is equals to x. So x1 by y1, so x1 is equals to y1 tan theta 1, which is equals to, similarly x2 is equals to tan y2 tan theta 2. So substituting this, we have y1 tan theta 1 plus y2 tan theta 2 minus L equal to 0. So this is our constraint, and this needs to be minimized. Therefore, we write our Lagrange L as y1 c1 cos theta 1 plus y2 c2 cos theta 2 plus lambda y1 tan theta 1 plus y2 tan theta 2 minus L. And note that L is a function of theta 1, theta 2 and lambda. Here so by adjusting the angle theta 1, sorry, Sorry, 1 second. We have the Lagrange operator L as a function of theta 1 and theta 2, as theta 1 and theta 2. Depending on that, the values of x1, y1, x2 and y2 will be adjusted. Therefore, we'll take theta 1 and theta 2 to be the independent variable here. So now we have the first equation as dl by d theta 1 is equals to 0, which implies del by del theta 1 of y1 c1 cos theta 1 plus y2 c2 cos theta 2, and as this is a minimization problem, here there will be a negative sign. Minus lambda y1 tan theta 1 plus y2 tan theta 2 minus L equal to 0. Which gives us y1 c1 sec theta 1 tan theta 1 minus lambda y1 sec square theta 1 equal to 0. Similarly, if we do del L by del theta 2, which is equals to 0, will give us y2 c2 sec theta 2 tan theta 2 minus lambda y1 y2 sec square theta 2 equal to 0. Let's say this equation is 1 and this equation is 2. From both the equations we get, from equation 1 and 2 we can rearrange and get y1 by c1 sec theta 1 tan theta 1 is equals to lambda y1 sec square theta 1. So the y1 gets cancelled and 1 sec gets cancelled, and we have this equals to sine theta 1 cos theta 1 into 1 by c1 is equals to lambda by cos theta 1. So again we can strike off the cos theta 1, which gives us sin theta 1 by c1 is equals to lambda. Similarly, we have sin theta 2 by c2 is equals to lambda, which gives us the relation sin theta 1 by c1 is equals to sin theta 2 by c2. Therefore, the correct option is sin theta 1 c1 is equals to sin theta 2 c2. So this is from, we come to the end here. Next week we'll discuss solutions of week 5. Awesome. I'll stop here. If there's further any doubts or anyone joins, I'll take them up.